Welcome everyone. Let's begin our lesson for today by going over the learning goals and success criteria. First, what are we learning? We're learning how to recognize patterns in arithmetic sequences and write their corresponding sequence equations, how to find a given term for an arithmetic sequence, how to recognize patterns in geometric sequences and write the corresponding sequence equations, and how to find a given term for a geometric sequence. How are we learning it? Through the No Term Limits Part 1 notes and the No Term Limits Part 1 assignment. When can we use this information? To recognize patterns in order to recognize trends in the stock market or housing rates. How do you know you learned it? By getting a score of 4 on the No Term Limits Part 1 assignment. Now let's take a look at our agenda for today. We will begin by going over the learning goals and success criteria. While we do that, you'll fill out your Get It Started. Once you've completed your Get It Started, we'll go over it together and answer any questions that you may have. After that, we'll go over the No Term Limits Part 1 notes, and then I'll give you time to complete the No Term Limits Part 1 assignment on Desmos. Once you've completed the assignment, we'll go over it together and answer any questions that you may have. At the end of class, we'll go back over our learning goals and success criteria while you fill out your Before You Go. Your only homework for tonight is to continue working on the Arithmetic and Geometric Sequences study guide and any incomplete assignments that you may have. Let's take a look now at the No Term Limits Part 1 notes. The notes begin with the learning goals and success criteria. What is an arithmetic sequence? An arithmetic sequence is a sequence of numbers in which each term is found by adding the same number to the previous term. So an example of this would be 2, 4, 6, 8, 10, etc. So each time we move from one to the next, we're adding 2 to it. So 2 plus 2 is 4, 4 plus 2 is 6, 6 plus 2 is 8, and so on, and it goes on forever. Notice that there's a common difference of 2 between each term in the sequence. So let's take a look at the table. So we have our months, and we look and see that there is a steady change. We're adding by 1 month each time. And in rainfall, we can see that we have a consistent change also. We are adding by 2 inches each month. Therefore, if we were to plot these points, it would look like this, and therefore we can see it does form a straight line, and yes, it is linear because we have a consistent change of addition and a consistent change of addition. So predicting a pattern, so if we're given the pattern of 2, 4, 6, 8, 10, and we're asked what is the common difference? Well, we should notice that every time we go up 2, so the common difference is 2. So the question is, what would be the next term in the sequence? So after 10, what would be the next one? So we know that we're going up by 2 each time. So we add 2 and we get 12. So the next term would be 12. Again, we have a situation where we know the common difference is 2. Now, what if I asked what is the 8th term? So we have 1 term, 2, 3, 4, 5. So we need 3 terms later. So we're going to go ahead and add 3 terms. So we add 2 and 2 and 2, and we get 16. So we know that the 8th term would be 16. Now, is that always easy to find? No, depending on the term, we don't want to have to keep calculating out. So the easiest way to do this is to write it in explicit form. So the explicit form for an arithmetic sequence is a to the n, meaning the value that we're trying to find, is equal to d, the common difference, times the number that we want, minus 1, plus the first term in the sequence. So an is the term we're trying to find. So for instance, a7 is the 7th term in the sequence. D is the common difference. N is the number of the term that we're trying to find. And a1 is the first term in the sequence. So let's look at an example. We have a pattern here, 2, 4, 6, 8, 10. The explicit form then is an is equal to d times n minus 1 plus a1. Well, we know d and we know a1. So we know d is 2. That was the common difference. And a1 is 2 because that's the first term in the sequence. Now let's take a look at this one. So we're given that an is equal to 3 times n minus 1 plus 4. And we want the 5th term. So 3 is our common difference. 4 is our first term. And we want the 5th term. So we're just going to plug 5 in for n. So this becomes a5 is equal to 3 times 5 minus 1 plus 4. Now we're just solve it. So 5 minus 1 is 4. So we're left with 3 times 4 plus 4. Well, 3 times 4 is 12 plus 4 is 16. So the fifth term in that sequence would be 16. So look at another example. Let's try to find the 10th term of this one. That's an is equal to negative 4 times n minus 1 minus 3. So again, we plug in 10 for n. So this becomes a10 is equal to negative 4 times 10 minus 1 minus 3. Well, 10 minus 1 is 9. So we have negative 4 times 9 minus 3. Well, negative 4 times 9 is negative 36 minus 3. Negative 36 minus 3 is negative 39. So the fifth term in that sequence is negative 39. There's a video here that shows you how to find the common difference for an arithmetic sequence using Symbolab, so you can watch that video. Let's take a look now at how we can find a common difference from an arithmetic sequence. So we went to Symbolab and went to their arithmetic sequence calculator, and we're going to go here to where it says common difference. And it asks, what's the sequence? So we're going to put in the first 2 or 3 terms. So if it's given as an equation, that's okay. We'll just figure out what the first couple terms are. So let's say it's 3, 7, and 11. So that's our sequence. And we can go ahead and click go. And it will tell us everything we need to know. So it'll write out the equation for us. This is what it should look like in the equation. And it tells us D what the difference is. The difference is 4. So this is how we can use Symbolab to find the common difference for our arithmetic sequences. There's a video here that shows you how to find a given term in an arithmetic sequence. So you can use this to check your work. So you can go ahead and watch this video. Let's take a look now at how we can check our work using Symbolab to find a given term in an arithmetic sequence. So we go to Symbolab and we go to the arithmetic sequence calculator, and we're going to click on the one that says value given index. So I'm going to click on that one, and it asks us for the sequence. Now it prefers to receive the sequences in terms of numbers. So if they give you the equation, that's okay. Just find the first 2 terms. That's all you really need. So I'm going to go ahead and put in the first term as 2 and the second one as 7. And then I'm going to put in the term that I'm looking for. So let's say I'm trying to find the 9th term. So I'm going to go ahead and enter that in, and I click go. And if I scroll down, it gives me the equation here that I'm looking for. And then it computes it for me and tells me that the 9th term should be 42. So this is how I can check my work using Symbolab when trying to find a given term of an arithmetic sequence. What is a geometric sequence? A geometric sequence is a sequence of numbers in which each term is found by multiplying the same number to the previous term. An example of this would be 2, 4, 8, 16, 32. What you should notice is every time we move from one term to the next, we have a common ratio or a multiple of 2. So we're multiplying 2 times 2 to get 4. 4 times 2 is 8. 8 times 2 is 16, and so on. How can we recognize exponential functions from a table? Well, first of all, the rule is the number of months, my x values, should be changing by a consistent amount, and it should be addition. And my y values should be changing by multiplication. So in this case, we have the months. So this is 1, 2, 3, 4. Well, is there a steady change in the number of months? Yes, there is, and it's changing by 1 month each time. Now here we have 2, 4, 8, 16. There is a steady change, and it is multiplication. We're multiplying by 2 each time. 2 times 2 is 4. 4 times 2 is 8. 8 times 2 is 16. So we're seeing a steady change, and it's multiplication. It is doubling, or multiplying by 2 each month. So therefore, is this exponential? Yes, it is. And if we were to plot these points, it would look something like this and form this curve. So we're given this pattern, 2, 4, 8, 16, and 32. And we want to know what the common ratio is. Well, we already talked about it earlier. Our common ratio is 2, and we found it by dividing this number by this number. So 4 divided by 2 is 2. So that's our common ratio. So what would the next term be? Well, we would take 32 and multiply by 2, and we get 64. So 64 would be our next term. Again, let's look at another example. What is the common ratio? We know that the common ratio is 2. Now, what would the eighth term be? Well, this is the 1, 2, 3, 4, 5 term. So we need to multiply by 2 3 more times. So this is 32 times 2 times 2 times 2. When we multiply that all out, we get 256. So our eighth term would be 256. Now let's talk about the explicit form for a geometric sequence. The explicit form looks like this. an is equal to a1 times r to the n minus 1 power. An in this case represents the term we are trying to find. For instance, a7 would be the seventh term in the sequence. R represents the common ratio. N represents the number of the term that we're trying to find. And A1 represents the first term in the sequence. So if we're given a pattern here, 3, 6, 12, 24, 48, we go ahead and fill this in. So AN we don't know. We do know A1 and we do know R. So AN is equal to, the first one is 3. And the R value, we're multiplying by 2 each time, so R is 2. So this becomes 3 times 2 to the n minus 1. Now let's take a look at an example. We have AN is equal to 3 times 2 to the n minus 1, and we want the fifth term. So we're going to take that and we're going to plug 5 in for n. So this is A5 is equal to 3 times 2 to the 5 minus 1 power. Well, we know that 5 minus 1 is 4. So we have 3 times 2 to the 4th power. Well, 2 to the 4th power is 16. Then we multiply that by 3 and we get 48 is our answer. There's a video here that you can watch on how to check your work when trying to find the common ratio for a geometric sequence. So go ahead and watch that video. Let's take a look now at how we can use Symbolab to find the common ratio of a geometric sequence. So we're going to go to symbolab.com and then we're going to find where it says Geometric Sequence Calculator. And I'm going to click here where it says Common Ratio. And it asks for the sequence. Let's say our sequence is 3 and 9 and then 27. So those are the 3 that we know. I'm going to go ahead and click Go. And it will tell me the equation right here. So it tells me exactly what the equation is. It should be a sub n is equal to 3 times 3 to the n minus 1. And it tells me exactly what my r, or my common ratio, is. My common ratio is 3. So this is how I can use Symbolab to find the common ratio of a geometric sequence. There's a video here that shows you how to check your work when trying to find a given term of a geometric sequence. So go ahead and watch that video. Let's take a look now at how we can use Symbolab to check our work when trying to find a given term of a geometric sequence. So we're going to go to symbolab.com and then we're going to go to the Geometric Sequence Calculator. And then down here I'm going to go to the one that says Value Given Index. And we're going to enter our sequence. Now, you may have the sequence been given to you as an equation. That's okay, just fine, like the first 2 terms, that's all you really need. So let's say the first term was 4 and the second term was 18. And the term we want is the 7th term. So we just enter our sequence in here and put our index here. Index is the term we want. And we're going to go ahead and click Go. And when we scroll down, it tells us exactly what our ratio is and exactly what our term should be. So our 7th term should be 531,441 over 16. So this would be our solution. So that's how you can use Symbolab to check your work when trying to find a given term of a geometric sequence. Now, how can we predict the next term in a sequence? So let's say we know the 20th term. How do we know then what the 21st term would be? So the way this works is we're going to find the next term in the sequence if the previous term is 57, given that an is equal to an minus 1 plus 4. So what we're saying is the term we want is equal to the previous term plus 4. So we know the previous term is 57. So we're going to plug that in for this one that represents the previous term. So we have 57 plus 4 is equal to 61. So that's how we use the recursive formula to find the next term. Now let's take a look at the recursive form for a geometric sequence. So that follows this pattern. an is equal to r times a to the n minus 1. Now, what we're really saying here is the term we're trying to find is equal to the common ratio times the previous term. So if we look at this one, we have an is equal to 4 times negative 1/2 to the n minus 1. And we want the fourth term. So we start here, and we're going to plug in 4 for n. And we get negative 1/2 to the third power. Well, when we multiply that out, we recognize that negative 1/2 to the third power is equal to negative 1/8. We multiply that by negative 4, and we get positive 1/2. So that would be the term that we're looking at. So let's look at an example here of working with recursive formulas. So we have an is equal to 3 times a to the n minus 1. And we know that the previous term is 21. So we plug 21 in here. So we get an is equal to 3 times 21. Well, we know that 3 times 21 is 63. So an is equal to 63. Let's talk now about how to sign in to Desmos to complete your work. So what we're going to do is you're going to click on the link to go to the assignment, and it should take you to a page that looks kind of like this. And right here where it says sign in with Google, we're going to click there. And it's going to pop up with our email accounts. You're going to click on your school email account, and it should already have you logged in because you should have already been logged in using Google Classroom. From there, I'm just going to click start the activity, and it will take me into the assignment and allow me to begin. So that's how you will log in to Desmos using Google. Let's take a look now at the No Term Limits Part 1 assignment. The assignment begins with the learning goals and success criteria. If we scroll down, there's a link here to take us to the Desmos activity. Go ahead and click on that link, and it should take us to a page that looks like this. We'll go ahead and click Start the Activity. The activity begins with the learning goals and success criteria. We'll go ahead and click Next. So it gives us a pattern and asks us to write the equation that goes with it. So we have 3, 29, 55. Well, it looks like we're adding by 26 each time. So this is a arithmetic sequence. So we would go ahead and put this in. So we put 26 times n minus 1 plus a1, which is 3. So there's my equation. Now, in order to make sure that this graphs it for us, we're going to change this to be y and x. And notice now, it graphed it for us. It says, what would be the 200th term of the sequence? So you're going to plug 200 in for x. Make sure you use a calculator. Or I can just put it in as 26 times 200 minus 1 plus 3. And notice Desmos did it for me, so it's 5177. So 5177 would be my answer. It says, what kind of function is formed from the graph? Well, we can see that it forms a straight line, so it's linear. It says, as n continues to grow, meaning as we continue to move to the right, what is happening with an? So as we move to the right, what's happening to the graph? Well, it's getting really steep and going up. So you'll just put that into words. Then we'll click Next. You'll do the same thing with this pattern. Now this one's the same, right? It looks very similar, 55, 29, 3. It looks exactly the same except it's in the other order. So you would go ahead and put the equation in for this one. Again, what is the 200th term? What kind of function is formed? And then what's happening? So as x is getting bigger, what is happening to y? You'll just state that in words. Now this one, we have fractions. Doesn't change anything. You'll go ahead and figure that out. Now notice though, it looks like we're cutting everything in half. So this becomes a geometric sequence. So now we'll go ahead and change this to be a geometric sequence. So we have a1, which is 9, times the common ratio, which is 1/2, right? Because every time we're cutting it in half, to the n minus 1 power. Now to make sure that it graphs it, we're going to change this to be y equals, and this is x. And notice now, we have our graph. What would be the 200th term? Again, make sure you use a calculator or let Desmos do it for us. So 9 times 1/2 to the, We're going to go ahead and put this in as 200 minus 1 power. Well, it gives us this equation here, and all this means is it's really, really small, okay? So you'll go ahead and put that answer in. And in reality, you can just leave it like this because the answer is over here, so that's good enough for me. And then what kind of graph is formed? Well, it's exponential. And then as x gets bigger, meaning we move to the right, what's happening to y? It's getting really close to 0. So that's what we would state there. Okay, then you'll do it again for this sequence. Then we have our graphs, and in reality, I didn't graph all of them, but all of your graphs should be here. And it says, what are the similarities do you notice between the two graphs? And then here it says, given what we know about the graphs, what kind of sequence do you assume that we are looking at? We should assume that we're looking at an arithmetic sequence because arithmetic sequences form linear equations. You'll do the same thing for this one. Both graphs should be here. Now, I only graphed one of them, so only one of them's here, but both graphs should be there. What similarities do you notice? And then what kind of graphs do you think we're looking at? Well, you should assume that we're looking at geometric sequences. Then we'll click next. Okay, it says, given that we have an arithmetic sequence with a positive common difference, what should the graph look like? Well, we know it should be going up then. So we just draw some kind of line that goes up. This time it says it has a negative common difference, so we know it should go down. So we'll draw a line going down. And then you're just going to state what's happening. So as x gets bigger, y is getting bigger here also, right? So as we move to the right, y is going up. So therefore, that's what you would state here. Just put it into words. Same thing here. We would have a line going down. So as x gets bigger, y should be getting smaller. So you'll just go ahead and put that into words there. You'll do the same thing for a geometric sequence. So you would graph what it would look like if r is between 1 and infinity, meaning it's bigger than 1. So if r is bigger than 1, then we should be going something like that. If r is between 0 and 1, it should be going something like this. And then you're just going to state, as x gets bigger, so as x gets bigger, y gets bigger. On this one, as x gets bigger, y is getting closer to 0. And then you'll do the same thing for this one. And then when you're done with the activity, you're going to go ahead and go back to your Google form and click Next. This will take you to your Before You Go. Go ahead and fill out your Before You Go and then submit your work on Google Classroom.